Okay, so in this lesson, this is the third review day for our exam, and we're going to review about hardware and software. Okay, so basically, we have, let's start with software. Okay, software has two groups, okay, two classifications. We have system software, and then we have application. System are the important softwares, for example, the operating system, we have virus checker, utility programs. And then application software are for specific tasks like Word or like video and things like that. Okay? Also, in here we have different copyrights. Copyright is to protect people's rights about their software, and you have different types. We have copyright. You cannot copy, okay? We have open source, where they give you the source code, and we talked about Linux, okay? And like Windows. Windows will be a software that's copyrighted. It usually has the C. And then open source, they give you the source code. Okay? And there's some benefits to that. There's commercial as well. And then there's freeware. Okay? So you have some software that's free to use for a specific time. Okay, so that's part of software. For the really important guy in this is the operating system. So what are some of the tasks that the operating system works with are interrupts. It gives you the graphic user interface. Okay, it manages the RAM. Like a file manager. What else does it do? Security for login. Permissions. File managed security, hardware management. All right. So that's basically it for software. Let's go into hardware. Now, the second part is hardware. Hardware is the physical components. We have primary storage. And we have secondary. Primary storage has two types. You have RAM and ROM. Secondary storage, you have multiple types. You have magnetic, optical, like the CD, SSD, sorry, that's not magnetic. We have the hard drive. Optical is like CD. We have cloud storage. We have logic gates, flip-flops, that's SSD, solid state drives. Okay? That's basically, okay, RAM, there are different types of RAM. There's SRAM, and there's D, dynamic RAM, static, and this is uses the capacitors. This uses the logic gates. ROM, you have several types. There's EEPROM, EEPROM, and EEPROM. And the purpose of that RAM is it has the BIOS, basic input output size. It's used for boot loading. Boot loading. That's when it loads your operating system into RAM. It's used for firmware. For loading the inputs, outputs, drivers. Okay, it has system time in there. System time. You can change into the BIOS. That's for booting up your computer. Okay. Now, the second thing we talked about is about the CPU architecture. You have the bus system, you have CPU, then you have RAM, and the thing that connects it is the bus. The bus system has three parts. What is a bus? Is basically the wires for data. So you have data bus, you have the control bus, and the data address bus. And this is all known as the bus system. And that's for communicating on your motherboard. Okay. Now, within the CPU and this whole component, we have the von Neumann, not architecture. And basically that is when you have RAM, and you have your address, and then you have your opcodes. And this we'll go into later, but opcodes, for example, LDD, you have instructions, and then you have data. And then we have data. And you have different addresses in here, and then you have your different commands and some data there. So that's the von Neumann architecture. And the thing that you need to know is the CPU cycle. We have fetch, decode, execute. And that's for every clock cycle. Okay. And we have these special registers. For example, we have the memory address register, which is called MAR. We have the CIR, the current instruction register. Every time it goes to the next thing, we call the program counter. We have the ACC, or the Arithmetic Logic Unit, which includes the control unit, I believe, and the ACC. But you basically need to know those registers' names and what the function they do, and then later they will give you assembly code to trace through. So let's have a quick look about those. So program, we have the register, transfer, notation, and that kind of explains the different thing. And the one that you have to know is the fetch. And basically, it's the program counter. These are the steps in the fetch code. We start with the incrementation of the program counter. Then we have the memory address register. The data in the address is copied into the data register. And then the memory address register is updated with the data that the program counter is pointing to. And then the current instruction register is going to be updated with the data in the memory address register. Memory address register. So this is basically the only part is the fetch part of the code that you have to understand, and the definitions, like what is PC. It points to next instruction. To be done. Okay. Memory data register. It holds the data to be executed. Memory address register holds the address data. Current instruction register holds the instruction to be executed. All right. Yeah. And the ACC, or arithmetic logic unit, is basically it does the processing, and the final results is in the accumulator. That's the results. Okay. So that's for hardware. And we'll do assembly code tomorrow. I guess I can do some logic gates. The logic gates, you need to be able to draw AND, or not, XOR, and truth tables. So we have A, B, Q, A, B, Q, A, Q, A, B, Q. You need to be able to draw these gates That's the and. The or looks like a moon. The not, triangle up a little dot. Exclusive or is like the moon, but it's not connected. Okay? And this is going to be 0, 0, 0, 1, 1, 0, 1, 1. And is only on when both of them are on. Or is one or the other. Okay, these are the tables. And A is 0, 1, 1, 0. That's this opposite. And exclusive or. Exclusive or is only on if one or the other one on. Like that. So you need to be able to go from a diagram to an expression. This would be A and B, and then, so you kind of start here, and the connector part is here. The final thing is not. I guess I can't really join it here. I should put an AND gate right here. So AND C or D. And then this whole thing is knotted because the final output's knotted. This will be not. Okay, so you have to be able to do truth tables, diagrams, and the last thing was expressions. I think that's mostly everything. Let me just have a quick look. Grade 11, so data we did, computer systems. Have a look, we have the different parts of a PC, storage memory, operating systems, open source software, yeah. Logic gates, okay, diagrams, CPU architecture. Yeah, so that's everything. We're going to do assembly code tomorrow, and maybe a little bit about networking because we just have the 3 units there. So your homework is to do your exam review paper, okay? I printed out you should have a copy of the exam review paper there. Looks like this. And we finished this. We can do that, okay? We just did this right here. And we did this right here. Okay, so we just finished these. And we did this on the first day, so we already did these, check. So your homework, or your schoolwork, is to work on these practice questions, okay? We should have already got all these, bitmap, okay? These are day 1. And today, we did, what is piracy? When you don't follow those rules right here, okay? So this is your schoolwork right here. Right, that's it. Stop.